Chapter 12, where we're solving systems of equations. Okay, solving a system of equations means that you're finding the solution that would work in both equations, where it would make them both true. So we're trying to figure out some number x and some number z, a pair of numbers, x, z, that would make both negative 2x plus z equals 3 true and x plus z equals 0 true. In other words, it would come out equal for both of those. Now, there's a way to look at this on a graph as well. So I'm going to put it into Desmos. Let's put in our negative 2x plus, and I'm going to call it y instead of z for Desmos purposes, equals 3. And x, the purple line is the equation, is the graph for negative 2x plus y equals 3. And x plus y equals 0 is this black line. And you can see that they intersect right here at negative 1, 1. So we can see from this, there is one pair of numbers that would make both of these equations true. And we can test that by putting in negative 1 for the x and 1 for the z. So without calculating anything algebraically, sometimes you can solve these just by using the graphing calculator. So let's go in and test when x is negative 1 and z is positive 1. So we'll put this in to Desmos. I'm going to replace that x with a negative 1, and I'm going to replace z with 1. And you can see that that equals 3. 3 equals 3. So it is a solution. It came out equal for the top equation. And for the bottom equation, we'll replace our x with negative 1. And z was 1. That came out to 0, in which we can see over here it needed to equal 0. So on your homework, some of the problems are just very simple. It gives you an ordered pair, and you have to test it to see if it's a solution. A solution means it's making both equations equal, come out equal. Okay, now, what if we didn't have Desmos to do the graphing? Or what if our graph was giving us a decimal that, but we needed an exact answer? So say it's a decimal that's an irrational or something. So let's go ahead and solve this using a process called elimination. We want to eliminate one of the variables. Now I notice that my z's right here are, if I added those together, z plus z would be 2z. But if I subtracted them, z minus z, that would eliminate the z. It would go to 0. So let's do that. We want to somehow eliminate one of the variables. So I'm going to take my second equation and multiply that entire equation times negative 1. Multiply everything here times negative 1. So if I did that, if I take negative 1 times the x, I'd have negative x. Negative 1 times z would be negative z. Negative 1 times 0 is just 0. Now I can add these two equations together. Negative 2x plus negative 1x is negative 3x. Z plus negative z goes to 0, and it cancels out. 3 plus 0 equals 3. Now divide both sides by negative 3, and we get x is equal to negative 1, just like we expected. And then to get z, we take that negative 1 and we plug it back into the original. X equals negative 1 back into the original, and we can